Hello everyone. In this lecture, we are going to discuss about the topic Entity Relationship Model in Database Management Systems. First, let us see about what is an Entity Relationship Model. The Entity Relationship or ER model is the model which is used for identifying the entities to be represented in the database and also represents how those entities are related to each other. The ER data model specifies the enterprise schema that represents the overall logical structure of the database in a graphical format. The ER diagram explains the relationship among the entities present in the database, and it is also used to model the real world objects like a person, car, company, and the relationship that exists between these real world objects. In short, the ER diagram is the structural format of the database. Now, let us see the symbols used in ER model. ER model is used to model the logical view of the system from a data perspective, which consists of the following symbols. So, first, the rectangle is used to represent the entity set. Double rectangle represents the weak entity set. Diamond symbol represents the relationship set, and double diamond represents the identifying relationship set for the weak entity set. And we can see that the attribute A is underlined with the solid line which indicates the primary key, and in general the attribute is represented with the oval shape. Double oval represents the multi-valued attribute. Dashed oval represents the derived attribute. And we can see that the relationship R is connected to the entity E with the double line which indicates the total participation of the entity set in the relationship R. And we can see that A is underlined with the dashed line that indicates the discriminating attribute of the weak entity set. And some more symbols are given here. So this represents the cardinality limits, that is, it indicates how many entities in the left hand side can be connected to the entities in the right hand side through the relationship R. So if the line is without arrowhead, it indicates many, and with arrowhead it indicates one. So many to many means both the sides no arrows, so it indicates that many number of entities in the left hand side can be connected to many number of entities in the right hand side through the relationship R. And many to one, so left hand side no arrowhead, right hand side arrowhead is there to represent one. So many entities in the left hand side can be connected to one entity in the right hand side through the relationship R. And one to one indicates both the sides arrowheads. So one entity in the left hand side can be connected to at most one entity in the right hand side through the relationship R. We can also represent this cardinality limits with other notation like 1 double dot H. So here H can be either 1 or M, 1 indicating 1 and M indicating many. And here we have role indicator. So it indicates the role above the line which is played by the entity E in the relationship R. And we have ECA which is represented in the inverted triangle which indicates the specialization or generalization in ER diagram. Let us see about all these symbols in detail in the forthcoming slides with some examples. Before that, let us see about what are the components of the ER diagram. So ER model consists of the components, entities, attributes and relationships that exist among the entities in the database system. So it can be categorized into entity, attribute and relationship. Entity can be further categorized into two types, that is strong entity and weak entity. And attributes can be key attribute, composite attribute, multi-valued attribute and derived attribute. Relationship can be one to one, one to many, many to one and many to many. Now first let us see about entities. An entity can be either a living or non-living component. It showcases an entity as a rectangle in an ER diagram. For example, if a student studies the course, both the student and the course are the entities. So this diagram illustrates the entities. Here we have the two entities, student and course. So if you are considering one student, then it is called as an entity. And if it is considered as a set of students, then it is called as entity set. Similarly, one course is called as an entity and the set of course is called as entity set. Next, we'll see about relationship. The diamond shape showcases the relationship in the ER diagram. It depicts the relationship between the two entities. In the example shown here, both the student and the course are entities, and the study is the relationship that exists between these two entities. So, if the relationship is between one student, then it is called as a relationship. If it is between set of students and the set of courses, then it is called as the relationship set. Next, we'll see about attributes. An attribute exhibits the properties of an entity. It is illustrated with an oval shape in the ER diagram. So here we can see that the student is having the 4 attributes which is illustrated in the oval shape. That is roll number, name, address and age. Next, we'll see about the composite attribute. So an attribute that is composed of several other attributes is called as composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected to other ovals. So as shown here, name is the composite attribute which is further connected to other ovals, which indicates the first name, middle name and last name. So this type of attribute is called as composite attribute. Next, we have multi-valued attribute. Some attributes can possess more than one value. Those attributes are called as multi-valued attributes. So the double oval shape is used to represent the multi-valued attribute. So here we can see that the student contains the student entity can have the attributes roll number, name, age and phone number. So here phone number is represented as double oval, which indicates that more than one phone number can be there for a particular student. So that is what it is called as multi-valued attribute. Next, we have derived attribute. An attribute that can be derived from other attributes of the entity is called as derived attribute. So in the ER diagram, it is represented as the dashed oval. So here we can see that age is represented as the dashed oval, because this attribute can be derived from the other attribute called as date of birth. Next, entities can be categorized into two types. So one is strong entity and another one is weak entity. So first we will see about strong entity. A strong entity has the primary key attribute which uniquely identifies each entity. Symbol of the strong entity is same as the entity, which is nothing but the rectangle shape. So here we can see that we have two entity sets, that is customer and loan, which is connected through the relationship borrower. That means customer is borrowing the loan from the bank. So customer has the attributes customer ID, customer name, street and city. Loan has the attributes loan number and amount. So in both the entity sets we have the key attributes. So here for customer ID is the key attribute because it is underlined with the solid line. Here for loan we have a key attribute loan number which is underlined with the solid line. So we say that it is a key attribute because for loan only one loan number can be there. So loan number uniquely identifies the entity loan. Here also for each customer only one customer ID will be there. So it uniquely identifies the customer. So that is what it is called as primary key attribute. Next, we'll see about weak entity. So, an entity which does not have the primary key attribute and depends on other entity via a foreign key attribute, then it is called as weak entity. So, for example, in the bank, if we are borrowing the loan, there will be payment number for loans. So, payment numbers are sequential numbers starting from 1 which is generated for each loan. So, there can be multiple loans like education loan, personal loan, etc. So for each loan, the payment number generation is the same concept which starts from 1. So thus, although each payment entity is distinct, payment for different loans may share the same payment number. So thus, this entity set does not have a primary key and it is called as weak entity set. And the existence of the weak entity set depends on the existence of the identifying entity set or the owner entity set. And the relationship that connects between this weak entity set and the owner entity set, it is called as identifying relationship. And we can form the primary key of the weak entity set with the primary key of the strong entity set plus the weak entity set's discriminator. So here in this example we can see the concept. we have two entity sets, loan and payment. So loan is the strong entity set because it is having the primary key attribute loan number. So we have the attributes loan number and amount for the loan entity set, and payment is the weak entity set because it is not having the primary key attribute. It is having only the discriminator, which is nothing but the payment number. So the discriminator is indicated by underlining with dashed line, and we have other attributes, payment date, that is on which date the payment is done, and what is the amount which is paid. So here this payment entity depends on the loan entity. It is existence dependent on the loan. So only if the loan exists, the payment also exists. If the loan is deleted, automatically the payment is also deleted. And we are having the identifying relationship loan payment, which is illustrated in the double diamond, and we can also see that the payment is illustrated with the double rectangle because it is a weak entity set. Now let us see about the types of relationship. So first we have one-to-one relationship. So when a single element of an entity is associated with the single element of other entity, then it is called as one-to-one relationship. For example, a student has only one identification card, and identification card is given to one person. So here we have the example illustrating this concept. So student is one entity and identification card is other entity. So one student can have only one ID card. So this is representing the one-to-one relationship. We can also use the symbols like arrowhead to represent the one-to-one relationship, but here we have used the other notation, so we are mentioning the number 1 at the top of the line. And next, one-to-many relationship. So when a single element of an entity is associated with more than one element of the other entity, it is called as one-to-many relationship. For example, a customer can place many orders, but an order cannot be placed by many customers. So here we can see that one customer can place many orders. So this indicates the one-to-many relationship. Next, we can have many-to-one relationship. When more than one element of an entity is related to a single element of another entity, then it is called as many-to-one relationship. For example, students have to opt for a single course, but course can have many students, as illustrated in this diagram. So many students can enroll for one course, but one course is can be taken by many students. So that is the concept of many-to-one relationship. Next, many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity, it is called as many-to-many relationship. For example, we can assign an employee to many projects, and the project can have many employees as illustrated in this diagram. So employee is assigned to many projects, and many projects can be assigned to, and one project can be assigned to many employees. So that is the concept of many-to-many. Next, relationship sets with attributes. So if the relationship set is also having some attributes associated with it, then those attributes are linked with the relationship as shown in the below diagram. So here customer deposits the amount in the account. So we can represent the access date, that is when that particular customer has accessed the account lastly can be represented with the access date. So it is associated with the relationship depositor. So if you are having the attributes which is represented with the relationship, we can represent with the relationship set like this. So this is called as descriptive attribute. Next we have roles. So entity sets of the relationship need not to be distinct. The labels manager and worker are called roles. So they specify how the employee entities interact via the works for relationship set. Roles are indicated in the ER diagrams by labeling the lines that connect the diamonds to the rectangles, and it is optional and it is just used to clarify the semantics of the relationship. So here we can see the roles concept. So employee is entity set and relationship set is works for. So employee will work for a particular concern. So he may be a manager or a worker. So it is indicated by this role. Manager it is indicating that there can be one manager from the employees and many workers. So arrowhead indicates one manager and no arrowhead indicates the workers. There can be many workers. So this is optional. If you want, you can use this. Next, let us see about the participation constraints. So it is associated with the relationship set. So it is applied to the entity participating in the relationship set. So we have two types of participation, total participation and partial participation. First we'll see about total participation. So each entity in the entity set must participate in the relationship. If each student must enroll in a course, the participation of the students will be a total participation. Total participation is shown by double line in the ER diagram, and partial participation means the entity in the entity set may or may not participate in the relationship. If some courses are not enrolled by any of the students, then the participation in the course will be partial. So the diagram below depicts the relationship enrolled. So with the student entity set and the course entity set. So with the student entity set, it is having the total participation, and with the course entity set, it is having the partial participation. So it indicates that a student must at least enroll in one course. So definitely a student has to enroll in the course. So that is what it is indicated as double lines. So it is called as total participation. But a course might be there which may or may not have the students. So course is a entity which can participate or cannot participate in the relationship R. So it is called as partial participation. And here we are indicating the cardinality with the notation M. M indicates many. So many students can enroll any number of courses, that is N courses. So thus we have seen about the participation constraints, and we have seen about all the components of ER diagram in this lecture. Thank you.